Good evening, Doctor. We are from Group 4. We will be presenting about Pulse Oximeter project. We are out of four members of our group, which are Nurul Atira Iliana, Nurul Khairul Iliana, Nur Nabiha, and I myself, Yaswan Kumar Nair. Thanks. The executive summary is this project focuses on developing an IoT-based project, which is SpO2 and heart rate monitoring system for health facilities in Malaysia, which is using the max of 301 30,100 oximeter sensor. The system is crucial in the current COVID-19 era, employs integrated LEDs and photodetector and optimized optics to measure oxygen saturation and heart rate levels. Operating on a power supply between 1.8 volt and 3.3 volt, the sensor allows continuous monitoring with minimal standby current. Utilizing IoT, which is Internet of Things technology, ensures seamless integration into healthcare facilities while microprocessor calculates and records vital science data. The adoption of photodetector technology reflects a growing trend in Malaysia. This system not only addresses the need for advanced health monitoring but also elegance with the rising use of innovative technology in country's healthcare landscape. Next. So basically the introduction of our project is the Internet of Things, which are known as IoT, is a network facilitating communication among devices and in the cloud. It's harnessed in the Pulse Oximeter project. The embedded system play a pivotal role in enabling IoT, allowing devices to operate as a single application or connect to the internet and communicate with other network devices. So we used max 30,100 a sensor combining heart rate monitoring and pulse oximetry. Integrates, so this sensor integrates from LEDs and a photodetector, optimized optic, and low noise analog signal processing. So we developed this project using MicroPython and the UPCraft IDE. The project employs an ESP32 microcontroller, integrated sensor, and IoT technology to create a real-time pulse oximeter system for health facilities. This system provides operators with continuous SpO2 and heart rate data, offering alerts to maintain stable level and showcasing the versatility of embedded system in IoT application.
Okay, next for the problem statement. This project faces three primary problem statements. The first one is the pulse oximeter sensor may may give inconsistent reading due to the factors such as ambience, light interference, finger placement, or variation in skin condition. This inconsistency could lead to incurrency in SpO2 and heart rate measurement. The second problem statement is calibrating the pulse oximeter sensor for optimal performance might pose challenges, especially in environments with fluctuating temperature or when dealing with diverse user demographic. Difficulties in calibration could affect the accuracy of measurement. And the last problem statement is relentlessly capture and document SpO2 and heart rate data. Next. For the objective, there is three objectives of this project. The first one is to develop a system capable of measuring SpO2 and heart rate level without relying on the dedicated oximeter. The second one is to provide participants with hands-on experience in hardware setup, coding, and embedded programming. And last objective is establishing a Wi-Fi connection for assembled devices, assembling components, implementing embedded programming using MicroPython, and using the device for precise SpO2 and heart rate measurement. Next. And for the proposed solution, we propose to provide a clear user instruction and real-time feedback on correct finger placement to ensure accurate reading. The second one is to conduct extensive testing across diverse demographic groups during the calibration process to ensure accuracy across various user profiles. And lastly, institute a 20-second timer within the sensor to facilitate detection, allowing sufficient time and stabilization for stabilization and accurate data collection.
Next, we will continue for methodology. Methodology, there is software architecture. Software architecture, flow chart and software hardware specification. Firstly, software architecture, there is 4 layers, which is physical layer, service layer, and presentation layer. For physical layer, the physical layer comprises the sensor, node, and optical technology. In this layer, data is gathered and transmitted to the service layer. For service layer, in the service layer, the business logic begin implementation, storing all the collected data for future use. This layer is considered the most crucial in the system. And lastly, presentation layer. At the end of the process, this layer visualizes all the information to the user, enabling them to interact with the system. Next. For software and hardware specification, we use SP32 and the software specification UPCraft version 1. Pulse oximeter sensor MAX 30100 software specification for favor IOT and jumper wires and breadboard. Next. Okay, this is our flowchart. We will start and design circuit, then write the and upload to ESP32. Find if there is Wi-Fi or not. If not, we will connect again to ESP32. If yes, MAX 30100 indicate SPO2 and heart rate level. Then the data will send to Favor IoT and display SPO2 and heart rate level. Then end. So I will pass to Dr.Ahmad.
For result and discussion, just like what Harry Elena explained just now, but this is the physical to input and output. For the first thing that we do is finger touch is employed to activate the MAX 30100 sensor, prompting the display of both red and infrared light on the sensor. Once the information is obtained from the sensor, so the system proceeds to calculate SPO and heart rate level. Data generation versus 30 seconds. So in the 30 seconds, it will generate the data that they get from the sensor. So the following, which the system compute the average of SPO2 and heart rate. So upon obtaining the average, the information is stored in the Favor IoT. Subsequently, the Favor IoT send an email to the individual and the individual get notification. For conclusion, the industry benefits greatly from the adaptation of IoT as it makes device connectivity and communication possible. By taking into account the new characteristics and needs of the Internet of Things, such as connection, many IoT projects and embedded systems may be created and be used to assist humans in their everyday life. The pulse oximeter system for health facility is a promising solution for human health by machine that monitor oxygen saturation, SpO2 levels, and heart rate is crucial for examining these vital signs in our body. That's all from us. Thank you.